Around the world of today, the rubber tire stands as a symbol and a tribute. A symbol of safe, comfortable transportation. A tribute to man's skill and science. Into the building of this tire, man has poured years of research and experience. But he has learned much too. His first lesson was to use only the best of raw materials. So man has scoured the tropics the world over in search of better rubber trees. And he's arranged this selected stock into vast, orderly plantations. He's given his trees scientific care, kept them strong and healthy. He has been rewarded with an endless flow of that precious liquid called latex. And man has learned how to gather his latex efficiently, how to prepare it for processing, how to reduce it to convenient forms for shipping. Far across the world, in the great centers of civilization, man has learned something else about rubber. He has learned that he can create it for himself. Yes, with chemicals and machinery, man has produced synthetic rubber. A rubber of excellent quality. It is from these two types of rubber, synthetic and natural, that the modern tire is made. Now, many people think that a tire is made entirely of rubber. But if we look at one in cross-section, we find that rubber is used principally in the sidewalls and tread, while the body of the tire is made from cords of cotton, rayon, or nylon, and treated with rubber to give it strength and flexibility. The bead of the tire is made of high-tensile steel wire, which is also rubber-treated. But now, let's see how all these separate parts are processed and how they are used in the building of a tire. We'll begin with the rubber, just as we find it in the warehouse at the tire factory. Here are many different types and kinds of rubber, both natural and synthetic. The natural rubber, brought from tropical regions around the world, has been processed for shipping in several different ways. This rubber from the Firestone plantations in Liberia, for instance, has been rolled into large, thin sheets. And here is another kind of sheet rubber, pale crepe, product of the Dutch East Indies. This type of crepe rubber can also be pressed into bales. This is a bale of high-quality synthetic rubber made right here in America. The first step in building a tire is to feed the baled rubber into a large cutter. Tremendously powerful, this machine slices the toughest bale as if it were a slab of butter. After the rubber has been cut into chunks, it begins its movement through the Firestone factory. So let's move along with the conveyor as it delivers the rubber to the plasticator. The plasticating machine looks very much like an oversized meat grinder, and an X-ray view shows us that it works on much the same principle. However, the rubber is not actually ground into particles. It is simply kneaded and softened. As the stock emerges from the plasticator, we see it has become a continuous ribbon of soft, pliable rubber. It is immediately cut into pieces of uniform length, then placed on a conveyor to be carried to a large mixer, known as a Banbury mixer. Here it is further kneaded and softened. Next, the rubber is dropped into the pelletizing machine, where an automatic ram pushes each batch into a large worm screw. The screw carries the rubber along to the head of the machine and forces it through a perforated cylinder. We're looking at the cylinder head-on now, with the housing removed. We see that as the rubber is extruded, it is immediately cut off by a series of rotating knives. Thus, pellets of uniform size and shape are formed. To dissipate frictional heat, the pellets are water-cooled in a separate unit, then carried by a series of screws through a drying process. And finally, They're dropped into a storage bin. Mechanical compounding comes next. This is the modern way of blending and mixing the rubber pellets with chemicals. These chemicals are added to raw rubber, and after vulcanization, give rubber the qualities of toughness, elasticity, age resistance, and long wear. The powdered chemicals are weighed automatically and delivered to an endless belt. We'll call it belt A. While this is going on, a batch of rubber pellets is being weighed onto another belt, belt B. When both belts are set in motion, they carry their materials to a chute, which delivers everything into a Banbury mixer. Liquid chemicals are added, and all the ingredients are thoroughly blended and mixed in the Banbury. This is mixer number 1. As soon as it's busy, a second batch of chemicals is already being prepared for mixer number 2. From a second container, another batch of pellets is being weighed out on belt C. Now belt A rotates in the opposite direction. Belt C delivers its cargo of pellets, liquid chemicals are added, and mixer 2 goes into action. Thus we see that automatic compounding ensures accurate and efficient mixing of all materials. When rubber and chemicals have been thoroughly mixed, they are dropped into a large mill. The purpose of this mill is to flatten the rubber between rolls, so it may be cut into strips, which are then conveyed to another section of the plant. Before we move along, however, we're going to pause here long enough to watch as a sample is taken from this particular batch of rubber. You see, in a Firestone factory, nothing is left to chance. A sample must be taken from every batch and sent to the laboratory, where it will undergo rigid tests for strength, elasticity, and uniformity. In the laboratory, the rubber sample must first be vulcanized. In other words, cured with heat. Remember, our sample contains not only rubber, but also certain chemicals. It is heat that puts these chemicals to work. When the rubber emerges from this vulcanizer, it will be tough and elastic. After the sample is vulcanized, a small ring is cut from it and placed on the stretch tester. If the ring can be stretched to a specified length without breaking, it's considered okay. Well, looks like our sample made the grade. This is a test for specific gravity. If the sample has the correct chemical balance, it will float in a certain solution. Our sample passes the test. Now let's find that batch again. Here it is, in the sheeting mill, being rolled into sheets of uniform width and thickness. These sheets are again automatically cut into shorter lengths for easier handling. The rubber is now ready to be used in making all the different parts of the tire. However, we started out to build the tread and sidewalls, so let's stay with it. Let's follow this batch to the warm-up mill. Now, this mill does just what its name implies. It warms the rubber, makes it soft and easy to work. As soon as it's thoroughly pliable, the rubber is peeled off in strips. These strips become another endless ribbon, and this ribbon will become the tread and sidewalls of the tire. The tread is formed in the tread extrusion machine. Here, the rubber is forced through a die, which reduces it to the proper size and shape. It's as simple as that. Now, in a moment, we'll catch up with the tread and see what happens to it. But first of all, let's point out that while the tread is being formed, a larger die is squeezing out the sidewalls for the tire. If we follow the sidewalls along, we'll see how the two elements are brought together. This is the tread coming down from the top. But let's watch this in diagram. Here's a cross-section of what we've been seeing. Notice how the sidewalls have been formed to receive the tread. And here it comes. A perfect fit. Now, to complete the job, these two elements must be sealed together. And this is done by applying pressure with these two wheels. Frictional heat is dissipated by spray cooling. And finally, the tread and sidewall unit is cut to specified lengths, ready for tire assembly. But all that will be explained later. We still have two important sections of the tire to talk about. Let's take the cord body next. You see, it's cotton, rayon, or nylon that gives the tire strength and helps hold it together. So starting here in the warehouse, let's follow the material through the plant and see how it's processed. The first operation is gum dipping. And while the men are setting the roll in position, let's examine this material more closely. If we magnify it, we see it's composed of a number of cords laid side by side and all running in one direction. When these cords are gum dipped, they become coated with rubber to form safety-lock gum dip cords which provide extra strength and protection against blowouts. Now, let's continue in diagram and see how the process works. The cords are fed directly from the roll into a large tank, which contains a specially compounded rubber solution. When it emerges, every single cord has been coated. Next, the cords pass into a large heated room. The heat not only dries them, but keeps them in a soft, pliable condition. With the operation completed, the gum dip material is again wound into a large roll, ready for